Okay guys, we're going to go through goals 5 and 6. So goal 5 says I can manipulate the general term formula for an arithmetic sequence to find unknowns. Example 1. Find the general term un for an arithmetic sequence that has u7 equal 41. So the seventh term of this sequence has a value of 41. And u13 equals 77. We remember that un for an arithmetic sequence is equal to u1, the first term, plus n minus 1 times d, the common difference. So in this case, we don't know our u1 and we don't know our common difference. We only know the value of these two terms in our sequence. So we can't just plug and play here with the u1 and the common difference like we did in goals 3 and 4. But what we can do is set up two separate equations using this information and solve them as a system of equations. So if I start with u7 equals 41, the value of the seventh term is 41. So I have 41 equals u1 plus 7 minus 1 times d. Simplifying that a little bit, we get 41 equals u1 plus 6d. Looking at the other equation here, I know that the value of my 77th term, or my 13th term, is 77. So 77 equals u1 plus 13 minus 1 times my common difference. So 77 equals u1 plus 12d. Now we have two equations with two unknowns, u1 and d. And we can solve these equations using either substitution or elimination. Substitution is when you solve for a variable in one equation and plug it into your other equation. Elimination is when you stack the equations on top of each other, add them together, and hope something cancels out. In this case, we're going to choose to use elimination because all of our variables are lined up. Our equations look exactly the same. Our variables just have different coefficients. And what we want is for the coefficients on one of your variables to cancel out with the other one when you add these together. So here I have positive u1. The coefficient here is positive 1. Over here I also have a coefficient of positive 1 on my u1. So I'm going to multiply this whole equation by negative 1. That's going to change my coefficient on u1 to negative 1, meaning that my u1s are going to cancel out when I add these together. So when I multiply by negative 1, I get negative 41 equals negative u1 minus 6d. So starting from the right side, I have 12d minus 6d. That's going to leave me with 6d here. I have u1 minus u1. Those are going to cancel out. And I always want one of my variables to cancel out when I'm doing elimination. Finally, I have 77 minus 41, which gives me 36. So 36 equals 6d. To solve this for d, I need to divide both sides by 6. 36 divided by 6 gives me 6. So I now know that my common difference is 6. I still need to find u1. In order to do that, I can take my common difference and plug it into either of my original equations. I'm going to choose this equation because the numbers are smaller. So I've got 41 equals u1, which I still don't know, plus 6 times my common difference, which I just found out is 6. So solving that a little bit, I have 41 equals u1 plus 6 times 6, which is 36. Solving for u1 here, I need to subtract 36 from both sides. 41 subtract 36 gives me 5. And I know that my first term, u1, is going to be 5. I'm almost there, but the question asked me to find my general term formula, so un. So un is equal to u1, which is 5, plus n minus 1 times my common difference, which is 6. This is okay, it would be a more complete answer if we distributed the 6 on both terms in the bracket here and simplified. So I have un equals 5 plus 6 times n, which is 6n, plus 6 times minus 1, which is negative 6. Collecting like terms here, I have u1 equals 5 minus 6, which gives me negative 1, plus 6n. This is your final answer. This is your general term formula. The second example that we have here for these two goals has to do with goal 6, solving problems involving arithmetic sequences. So let's take a look at that now. Atticus is getting very famous and receives a lot of fan mail. The first day, he receives 7 letters. Each day after that, he receives 3 additional letters. We need to find the number of letters he receives on the 8th day. So we're going to set up a general term formula here, un. So un is equal to u1. So in this case, u1 is how many letters he receives on the first day, which is 7. Plus n minus 1 times the common difference. So each day after the first day, he receives 3 additional letters. So 3 is our common difference there. Simplifying that, we need to distribute this 3 on our bracket. So I get un equals 7 plus 3n minus 3. I can collect my like terms here, and I'm left with un equals 3n plus 4. So that will let me find the number of letters that Atticus receives on any given day. So in this particular example, we need to find the number of letters he receives on the 8th day. So that means that n equals 8. So we're looking for u8 equals 3 times n, which is 8, plus 4. 3 times 8 is 24, plus 4 equals 28. So on the 8th day, Atticus has received a total of 28 letters. It says, after how many weeks does Atticus receive 64 letters? Keyword here is weeks. So let's find the number of days it takes for him to receive 64 letters and see how many weeks that translates into. So here our un is going to be 64 because our term number here, we're not sure. We know the value of our term is 64. So 64 is going to equal 3n plus 4. So solving for n here, we need to first get rid of this constant term. So we're going to subtract 4 from both sides. 64 minus 4 gives me 60, and that equals 3n. Finally, to get n by itself, we need to divide both sides by 3. 60 divided by 3 gives me 20. So it's going to take 20 days for Atticus to receive 64 letters. How many weeks is that? There's 7 days in a week. So 3 weeks would be 21 days. 2 weeks is only 14 days. So we know we're more than 14 days, but we're a little bit less than 21 days. But in order for him to receive 64 letters, 3 whole weeks have to have gone by. Part C says, after how many days does Atticus receive 82 letters? So again, our un here is going to be 82, and we're looking for the term number there. So we've got 82 equals 3n plus 4. So solving for n here, we need to subtract 4. That gives me 78 equals 3n. Dividing both sides through by 3 here to get n by itself, we have 78 divided by 3, which gives me 26. So it will take 26 days for Atticus to have received 82 letters in total.